to Educator.com. In today's lesson, we're going to be covering solving absolute value equations. Recall that the absolute value of a number x, written as x with the two bars, this is a symbol for absolute value, is the distance from x to 0 on a number line. For example, if you have the absolute value of x equals 3. What you're saying is that the absolute value of this number is 3 away from 0 on the number line. 1, 2, 3. Okay, so looking at this, if I go from 0 to 3, this is 3 units away from 0 on the number line. Therefore, x could equal 3, because 3 is 3 away from 0 on the number line. However, consider this. Negative 3 is also 3 units away from 0 on the number line. So x could also equal negative 3. So if the absolute value of x equals 3, x could be 3, since the absolute value of 3 is 3, and x could be negative 3, since the absolute value of negative 3 is also 3. So knowing this and really understanding this definition will allow you to solve equations involving absolute value. Again, absolute value equations, so you can solve equations containing absolute values using the definition of absolute value. For example, 9x plus 2 equals 29. Well, I already said that if the absolute value of x is 3, that means that x equals 3 or x equals negative 3. So you can apply that same concept right here. 9x plus 2 equals 29 or 9x plus 2 equals negative 29. So once you've removed the absolute value bars, and you can do that by turning it into two related equations, one where it equals the positive and one equals the negative value. Once you've done that, all you need to do is solve each equation. So I'm going to solve just using my usual techniques. Subtract 2 from both sides. That gives me 9x equals 27. Over here, if I subtract 2 from both sides, I'm going to get 9x equals negative 31. Then I'm going to divide both sides by 9. Okay, so you handle the absolute value equations the same way, even if it's more complex. The other thing to keep in mind is that sometimes you have to first isolate the absolute value expression on the left side of the equation. For example, if you were given 3 times the absolute value of 5x plus 4 equals 6, the first step would be to divide both sides by 3. Because once you've done that, then you've got the absolute value isolated, and you can proceed by saying 5x plus 4 equals 2, or 5x plus 4 equals negative 2, and then solving both of those. In some situations, some absolute value equations where the absolute value equals c, if c is less than 0, these have no solutions. So if it says that the absolute value of x is a negative number, then there is no solution, and we just say that the solution is the empty set. And to make this more concrete, if I said the absolute value of x equals negative 4, well, there's no situation where an absolute value is going to be a negative number, because remember, the distance between 0, absolute value is defined as the distance between that absolute value and 0 on the number line, and you can't have negative distance. So there's no solution here, and instead we either just write the empty set as such or like this, indicating that there is no solution. So we just talked about a situation where there is no solution. An absolute value equation can have 0 solutions, which we just discussed, that's the empty set, 1 solution, or 2 solutions. And it's important to check each answer to make sure that it is a valid solution. For example, if I have the absolute value of x plus 4 is equal to 9, I'm going to go ahead and solve that using the usual technique of turning it into two related equations. X plus 4 equals 9, and x plus 4 equals negative 9. I'm going to solve that. X equals 5. Here, I'm going to get x equals negative 13. So let's check this by going back to the original, x plus 4 equals 9. If x equals 5, then I'm going to get 5 plus 4 equals 9. So the absolute value of 9 equals 9, and that is true. Since this is true, this is a valid solution. X equals 5 is a valid solution. Okay, doing the same thing for my other solution, x plus 4, absolute value of x plus 4 equals 9. Trying this, negative 13 plus 4 equals 9. Well, negative 13 plus 4 is negative 9, so the absolute value of negative 9 is 9. This is also a valid solution since this is a true statement. So here I have two solutions. Previously we discussed that, so there's two solutions here. We just discussed that if you end up with something like, x, the absolute value of x equals negative 6, there's no solution. It's the empty set. The situation where you can get one solution is if you end up with the absolute value of x equals 0. So if I went to solve this, I'd say x equals plus 0 and x equals minus 0, but that really doesn't make sense. There's just 0. So therefore, there's only one solution, x equals 0. So here I have one solution. So three possibilities: no solution, one solution, or two solutions. Or you may think you have two solutions, and then you go back and plug them in and find out one is not valid. And in that case, you could have something like this that appears that it would end up with two solutions, and it only ends up with one, or possibly even none. Okay, example 1. Evaluate for x equals negative 3, and this is multiple absolute value terms here. So substituting in negative 3 for x. Okay, solving for the absolute value of this would be 3 times negative 3. That's going to give me negative 9 minus 4. Here I have 2 times negative 3. That's negative 6 plus 3 minus 3 times the absolute value of negative times the negative is positive. Okay, this is negative 9 minus 4 is the absolute value of negative 13 plus negative 6 plus 3. That's negative 3 minus 3, absolute value of 3. Now I just need to find the absolute value for each of these. Well, the absolute value of negative 13 is 13. The absolute value of negative 3 is 3. The absolute value of 3 is 3, but this time we're multiplying it times a negative 3. So it's negative 3 times the absolute value of 3, which is 3. So here, 13 plus 3, negative 3 times 3 is negative 9. So 13 plus 3 is 16, minus 9 is 7. Okay, so solving this by substituting in negative 3 for x, finding the absolute values for these three, and then this one's multiplied by 3, negative 3, and then simply adding. Example 2, I have an absolute value expression on the left, but it's not isolated. So the first step is to isolate the absolute value and then find the two related equations and solve them. So divide both sides by 4 to get that isolated. Now recall that the absolute value of x equals 2, for example. This means that x could equal 2 or x could equal negative 2, to just illustrate the definition of absolute value. So in order to get rid of these absolute value symbols, I'm going to create two related equations. 3x plus 4 equals 12, or 3x plus 4 equals negative 12. Then I'm going to solve both and check to make sure that they're valid solutions. 3x equals 8. So divide both sides. So I have 3x plus 4, so subtracted 4 from both sides. Okay. And then over here, I have 3x equals negative 16, subtracting 4 from both sides. So just doing these together. Now, dividing both sides by 3 is going to give me x equals 8/3. Dividing, here I get negative 16/3. Now, check each of these in the original. So that's 4, and that's times absolute value of 3x plus 4 equals 48. First checking this one, 4, and this is 3 times 8/3 plus 4 equals 48. So the 3's cancel out, and that gives me 8 plus 4, equals 48. So 4 times the absolute value of 12 equals 48. The absolute value of 12 is 12. So 4 times 12 equals 48. And it does. So this is valid. So this first solution is valid. Now, substituting in negative 16/3 again in this original. So that's 4 times 3 times negative 16/3 plus 4 equals 48. The 3's cancel out. That gives me negative 16 plus 4 equals 48. Negative 16 plus 4 is negative 12 equals 48. The absolute value of negative 12 is 12. So again, I come up with 4 times 12 equals 48, and that is valid. That is a true statement. So both of these solutions are valid. So this time I had two solutions, 8/3 and negative 16/3.